Hello and welcome to this guide. This will be the second video in a series showing you how to make a simple acoustic measurement setup for the workshop. If you haven't seen the first video and are unsure of what this project is all about, I recommend you to watch that first. It will be linked at the top of the description. The measurement setup that we want to make today is geared towards measurements on violins and violas. Modified versions for cello and guitar will work in much the same way, so that this guide can still be used. The parts just won't look identical to the ones I will be using today. Speaking of which, first we, of course, need to make sure we have all the parts necessary for the acoustic measurement setup. So let's go through them one by one. We will need 2 aluminium rods, 200 mm in length and 10 mm in diameter. An M8 threaded rod with a length of 210 mm. 2 linear bearings with an inner diameter of 10 mm and an outer diameter of 19 mm. 2 ball bearings with an inner diameter of 8 mm and an outer diameter of 22 mm. These here are of type 608Z. 4 M4 cylinder head bolts with a thread length of 10 mm as well as 4 M4 nuts. 2 M4 taper tip grub screws 5 mm in length. 4 M8 nuts, 3 of which should be of the locking type. If you don't have those, I have found that a drop of super glue turns a normal nut into a locking nut securely enough for our purposes. On the electronics side, we will need 8 200 mm long pieces of 0.14 square mm wire with an outer diameter of 1.1 mm and 4 10 mm long pieces of very thin wire. The one I have here is 34 AWG. At the ends of those wires will be 4 cinch type plugs and 4 electret microphones. 2 of these will be 6 mm in diameter and 2.7 mm in thickness, and the other 2 9.7 mm in diameter and 4.7 mm in thickness. All of this will be connected to a Behringer UCA202 audio interface, which we will need to modify. For this we need 2 4.7 kΩ resistors and 2 1 microfarad capacitors. These need to be of the ceramic type, so shouldn't have polarity. The basis for the build are 11 FDM 3D printed parts. The tools we will need are a pair of scissors, side cutters, a small knife, wire strippers, pliers, a screwdriver with M2 and M3 hex bits and a Phillips bit, a 13 mm wrench, a soldering iron, solder, soldering grease, a heat gun, heat shrink tubing, a multimeter, a poking tool, a small clamp, 2-part epoxy, and a plastic straw. A complete list of all the required parts and tools can be found as a handy table on the project's GitHub page. As you can see, I have tried to provide links to appropriate products in Germany and the US where I could. Please note that I haven't checked for best price or availability. This is just to help you with more details about the parts. Also, for some of the electronic components, I could not find exact products as of yet, so there are some question marks around the links. Okay, now that we have everything we need, let's begin with preparations. 3 of the electret microphones, both of the larger and one of the smaller ones, need to be closed off using 2-part epoxy. I like to do this in batches on a precise scale, so I can make sure equal amounts of epoxy go on each microphone. For this I use a plastic straw to get a precise amount and position. I pop any residual air bubbles in the epoxy by briefly exposing it to the flame of a lighter. For the purposes of this video, I will assume that all the 3D printed parts are already done. There will be a dedicated video about 3D printing in the future. Let me just highlight 2 special cases with the printed parts in this project. Both the top handle and the slider use embedded nuts, which means that the print has to be paused at the correct layer, the nut inserted and the print resumed. I took a similar approach with the top handle's grip. The grip itself needs to be printed first, and then the print for the handle can be paused at the correct layer and the grip slid on as you see here. Then once again the print is resumed, locking the grip in. Okay, with all of this out of the way, let's begin the actual build. First, insert 2 of the M4 nuts into the base. Next, screw in 2 M4 bolts. Here you can see that the length of the bolts needs to be exactly right at 10 mm, or they either won't reach the nuts or they will collide with the 3D print. Now we can insert the 10 mm aluminium rods into the base as well as one of the ball bearings. The rods can be locked in place by tightening the bolts. The procedure for the top part is very similar. Insert the 2 remaining M4 nuts, screw in the bolts and press in the ball bearing. The 2 linear bearings go into the slider component. The 2 grub screws can be threaded in. These should sit relatively tight so they don't loosen on their own. Next I have clamped the M8 threaded rod in a wooden vise. Then I thread on one of the locking nuts. The spacing to the end of the threads should be 25 mm. Remember to thread the slider part onto the threaded rod before you add the second lock nut. This one should be positioned at a distance of 6 mm from the end of the rod, so the measurement is definitely not correct in the video here. Now the slider assembly can be installed on the aluminium rods. Make sure the shorter end of the threaded rod is pointed downwards and inserts into the lower ball bearing. The assembly is locked into place by adding the top part and tightening the bolts. Finally, the handle is added to the top. You can thread it on by hand while holding on to the M8 threaded rod with a pair of pliers. You don't need to exert much force here, but the lock nut in the top handle should grip the threads. With the physical assembly mostly done, we can now start work on the electrical components. Thread 2 wires through the microphone arm. It is a good idea to color code them like I did here, to keep track of polarity. Strip the ends of the wires. This should be done rather short as shown here, as there is not a lot of space at the end of the microphone arm. Remember to add the shrink tubing to the wires before beginning soldering. Your microphone will have some indicator to show polarity. I will solder the red wire to the positive and the black wire to the ground terminal. Add some solder to the wires beforehand using a small amount of grease to make it flow. The small microphone needs to be held in some kind of clamp for us to be able to solder to it. Solder the red wire to the positive terminal and push the heat shrink tubing over the connection. Repeat the same for the negative terminal and briefly heat the shrink tubing with a heat gun. To achieve a low enough profile to fit through an F-hole, the microphone pins need to be bent flat against the back of the microphone. Finally, it can be inserted in the microphone arm. Now let's get to the other end of these wires. Again, strip the ends using wire strippers and add some solder to them using small amounts of grease. Before soldering anything to the connector, remember to push the wire through the cinch connector's cap, the insulating plastic piece that probably came with it, and the larger diameter piece of shrink tubing. Here I add another smaller piece of shrink tubing to the red wire. Now the red wire can be inserted into the positive terminal of the cinch plug and the retention bolt can be tightened. I push the small piece of shrink tubing to the front and heat it briefly with the heat gun. Then the black wire can be soldered to the negative terminal of the cinch plug. Again I use some flux to improve the flow of the solder. You can see here that after soldering I had a part of the wire sticking up. This could interfere with closing the connector, so I simply cut it with a small pair of side cutters. The cinch connector's strain relief can be bent down and the larger piece of shrink tubing pushed over it and briefly heated. Then the insulating plastic piece can be pushed to the front and the connector can be threaded together. And that's the microphone arm done for now, so let's get to the hammer part. Take the thin wire and strip the insulation from the ends. I use a pair of scissors for this, as you can see, but the flame of a lighter should work just as well. Then solder the thin wire to the thicker wire. Here it is already threaded to the slider component. I actually don't recommend doing it this way, just finish soldering the hammer on its own and slide the cable through later. After you have soldered both connections, protect them with some heat shrink tubing. Now thread the wires through the hammer. Again, remove the insulation from the ends and solder the red wire to the positive terminal of the larger hammer microphone and the black wire to the negative terminal. Again, I use grease to make the solder flow better. Then the microphone can be inserted in the hammer. This should be a tight fit. If your 3D print ended up slightly too large and this fitment is loose, add a drop of super glue to keep the microphone in place. Now you can push the cables through the slider part. Again, I did it the wrong way around when filming, so here I am showing the video clips reversed. You should push the cable from the front of the slider to the back, exiting between the linear bearings. Pull the cable into position so that the hole in the hammer lines up with the tips of the grub screws. Tighten these equally so that the hammer ends up centered in the front of the slider and can swing freely. Now, as before, let's add the cinch connector to the other end of the wires. Strip the ends and coat them with some solder. Then add the cinch connector's cap, insulation piece and heat shrink tubing to the wires. Insert the red wire into the positive terminal of the connector and screw it in. Add heat shrink and solder the black wire to the negative terminal. Bend close the strain relief and add the second piece of heat shrink tubing. Finally, bring the insulation plastic to the front and thread the connector closed. With the microphone arm and hammer assembly ready, we can clip the microphone holder to the aluminum rods and the microphone arm to the microphone holder, threading it through from the back as shown. Finally, we can add these cable management clips to keep everything tidy, and the measurement setup itself is done. In much the same way, you can make the handheld hammer and accelerometer. The only difference is that you don't need thin wire with the handheld hammer, as it doesn't have to be able to swing freely. Instead, I use some of the thin wire with the accelerometer to put less load on the object during measurements. The last and probably most complicated step is modifying the Behringer UCA202 audio interface. First, we will need to open it up by loosening 2 Phillips head bolts. Once inside, we need to identify those solder pads that we will connect to each other through the resistors and capacitors. The electret microphones need a 5V supply voltage. The USB port this interface runs off of supplies exactly this voltage. The terminal on the interface's board that receives it is the one that I have highlighted here. In all units I have seen so far, it has been connected with a red wire. We need to connect this to the ground terminal of each of the input cinch connectors. We will then make a connection from this terminal to a nearby inductor through the 1 microfarad capacitor. For this, we will first have to remove the existing connection between the ground terminal and the inductor. I scratch out the trace using a small knife, as you can see here. To make sure the connection is actually severed, I use a multimeter set to measure continuity. You can hear and see it detect continuity in this clip when I hold the 2 probes together. After scratching out the trace, I get no measurement of continuity when holding the probes against the negative terminal of the cinch connector and the nearby inductor. Therefore, I can know for sure that I have successfully severed the connection between them. I will wrap the resistors in heat shrink tubing to avoid shorting out any of the components on the interface. Use the smallest size of tubing that will fit over the resistor. When heating it with a heat gun, don't be like me and try to use your fingers to hold the resistors in place. Use some clamp or similar so you don't burn your fingertips like I did. Unfortunately, you can't see it here very well, but you will need to cut the ends of the resistors slightly shorter. Measure out the distance on the interface beforehand. One of them will need to be shorter than the other one, since the terminal it needs to reach is closer. Now solder one end of both resistors to the 5V terminal on the interface's PCB. Bend them into place so that they reach their respective ground terminals on the cinch connector side. Then solder both the capacitor and resistor to the ground terminal at the same time. Finally, bend the other leg of the capacitor into place and solder it to the inductor next to the ground terminal. Repeat this process for the second input and close the interface back up. Now the setup is complete and we can begin looking at how to use it for acoustic measurements in the next video. Thanks for watching this video and hopefully following along, making your own measurement setup. If you did, make sure to let me know how it went for you and if there are any questions or improvements to the design you would like to see. Until then, Luca.